Today we're going to learn how to create longer AI videos using a newly released tool called FramePack. We're going to explore how you can set it up and install it locally on your machine with as little as 6 gigabytes as VRAM, as well as explore cloud options in case you want to run more elaborate generations or you're running a system that doesn't have an NVIDIA graphics card. Now, in case you haven't realized, generating lengthy AI videos is one of the biggest challenges in AI video generation. Creating content that's more than 5 or 10 seconds long continues to be a massive challenge in the AI video space, with even major players like Kling and Sora struggling to create videos that is less than 10 seconds long. Now, some of these platforms do allow you to extend videos that you've generated beyond 10 seconds, but you have to first create that 10-second clip and then keep extending it. Or you have to use complex workflows in ComfyUI to try and get the desired results. No matter what you do, the biggest challenge is that as a video clip gets longer, the AI struggles more and more in retaining what's happening in the frame and understanding what's going on as the video gets longer. Not to mention the hardware requirements keep going up the longer your video gets. This has to do a lot with the way these video models are set up, where as you're generating video or extending the length of a video, the content at the beginning of the video becomes less and less important. What this means is that the prompt or the beginning frame or whatever you have happening at the beginning almost gets forgotten by the AI model as it generates longer and longer clips. This results in all sorts of weird things happening where strange creatures or elements start getting introduced into the video and the characters start to go in all sorts of random and weird directions. This is where FramePack comes in. Rather than taking a linear approach with AI video generation where, as I mentioned earlier, the further we get away from the beginning of the clip, the more gets forgotten, FramePack does things a little bit differently. Now, FramePack is not a brand new model, it's actually built on top of the Hunyuan AI video generation model. And the way it works is, first of all, it creates the beginning and the end of the clip that you're trying to create and tries to work backwards towards the middle to try and create a cohesive video where the beginning and the end kind of make sense. By doing this, it's kind of set up this context where it's always aware of what it has done before and where it needs to go. On top of that, it uses some additional AI tricks to better decide what frames are more important than others when trying to create this lengthy video. This way, instead of operating in a linear way, it uses some intelligence to try and get a little bit more context out of what you're trying to create. In theory, this should result in less strangeness happening in the video and the model having a better understanding of what it is that it's trying to create. The other really incredible thing about this model is the fact that it runs on 6 gigabytes of VRAM. That's right, with FramePack, you can run Hunyuan with as little as 6 GB of VRAM. And it does this by better utilizing the video RAM that you have and trying to pack in the context within that. The downside, however, is that when operating with less video RAM, particularly if you're trying to generate longer videos, it can take a long time to get that desired result. So in essence, all you're doing is exchanging VRAM for time. And I can tell you, when trying to generate a 30-second clip with my 3090 on 24 gigs of VRAM, well, I actually use about 17 or 18, it took well over an hour, I think almost 2 hours, to generate that 30-second clip, as it was generating about 25 frames every 4 to 5 minutes or so. And with each second being about 30 frames, it was generating just under a second's worth of AI video every 4 to 5 minutes. So keep that in mind when you're looking to use FramePack on your own local machine. If you're running low on VRAM, you better be ready to leave that machine running for a considerable amount of time. What I found works really well is use your own local machine for testing and experimentation to kind of get an idea of what you want to prompt and where you want to go in terms of the video, and then move to a cloud system where you can operate a lot faster, iterate a lot faster, and get your scenes out a lot quicker. And so today we're going to explore various ways to get started using FramePack, including local installations with G-Radio, ComfyUI locally, as well as a couple of options in the cloud, including running it on RunPod, as well as how it runs on Kaijugen, my own image and video generation service. So let's dive right in. So I'm going to start with the easiest method first, and that is using my own platform Kaijugen, because we've already got it set up here. So once you're signed up, you can go ahead and add in some credits here. We operate on a pay-as-you-go basis, so no subscription. Come on over here and select video, and then pick FramePack from all of the video options that we have available. Here, I suggest you open up the advanced parameters, where you can type in a negative prompt. In this case, I've got bad image, artifacts, and low quality. You can manipulate your CFG and guidance scale. I recommend not changing these. However, feel free to experiment to see if you get better results. You can also specify the number of frames here. And as I said, this model runs on 30 frames per second. So depending on how long you want the video to do, look at your number of frames, divide it by 30, and that will give you the average length of your video. So if, for example, we wanted it to be 10 seconds long, we would bring it down to about 300 frames. Then you can specify a seed, pick your resolution, 720 and 480, your aspect ratio, and then you can choose an image to be your starting frame, or you can generate an image using one of our image generation models, grab the URL for the image that you want to use, and then just pop in the image URL here, and it will use that same URL. Type in the prompt that you want, click generate, and it will start generating. And I've found that it works very quickly. I did a couple of test runs earlier for these 1-second clips, and it was done in like 10 seconds for a 1-second clip. So very fast, right? And here we have the dancer kind of performing a little bit of a dance. I will run a longer clip. Let's grab this one over here. We're going to drop that in here. And you can see here that it's set the image. And I'm just going to type in the prompt. Okay, and I'm going to make it 450 frames, which is about 15 seconds, which is 5 seconds longer than Kling or Sora typically let you do. Just for the sake of speed, I'm going to set it at 480p, and let's see how long that takes. So the video started generating. You'll see a placeholder pop up here. Now, typically if things take a little bit longer, you might see it disappear. Once it's done generating, you will get a notification that it's done. And there you have it, a 14-second video clip. This took about 6 minutes for us to create, so very good for a 14-second clip. Now, I will say that the video does have a couple of issues, but I think this has more to do with how I prompted it and the fact that we're using Hunyuan. I am planning to work on a prompting guide for Hunyuan, as you need to give it a little bit more detail to get good results, but you know, it's a 14-second clip. Quality is overall pretty good. The background is consistent, and the ship does try and do what I told it. You know, we can see here that it's starting to take off. It's moving towards the opening. This pilot probably needs to improve his skills a little bit. And I think it probably would have worked out if I'd gone for a longer clip. I'll try and regenerate this with a longer clip and try and put it at the end of the video if I'm able to get it done. But that's getting FramePack working on Kaijugen. Now, we're going to move from simplest to most difficult. So next, I'm going to show you guys how to get FramePack running on RunPod with G-Radio. Then I'll show you how to install the G-Radio locally on your Windows machine. Finally, locally on Linux. And then we'll look at ComfyUI, which you can run again locally or once again on RunPod. So for RunPod, it's incredibly easy to get started. I've actually put together a template for you guys, which will be a link down in the description below. And all you need to do is click on that link, and that will take you to a page like this, where you can pick the GPU that you want. So if we take into account that a 3090 took approximately 4 to 5 minutes per second of generation, then we probably want to try something a little bit more powerful. So let's try this 5090 over here. Now, you can choose to edit it if you want. I've given you guys 200 gigabytes of container and volume disk. You can increase this if you want, as the videos are saved on your volume disk. But you can go ahead and start it without anything. Just click Deploy on Demand, open this up over here, and check the logs. Now, it is installing a few things, and it is downloading the models before you get started. So if you're running this for the first time, it is going to take a few minutes to get up and running. But once it's done, you'll see here at the bottom of the logs that it gives you a G-Radio link. Once you have that, just copy and paste that into your browser, and you'll immediately be able to access the FramePack G-Radio. Okay, after maybe the first 1 to 2 minutes, you'll see the logs kind of stop here, where it shows you namespace, share true, free VRAM, 30 gigs, and so on. Don't worry, it's not stuck. It's just starting to download the necessary models. So give it a little more time. The models will download shortly. And there you have it. As I said, after a few minutes, it'll download everything, and you'll get a link like this. Go ahead and copy it, paste it in a new tab, and the FramePack G-Radio will load up. So very similar to Kaijugen, you can drop your starting frame in here, put in your prompt over here, and the G-Radio comes with a couple of preset prompts. You can set your seed. Unlike on Kaijugen, you actually set the length of your video in seconds, not in frames. You can adjust the number of steps to generate each frame. It's recommended that you don't touch this. Then you've got your CFG, which again is recommended not to be touched. Here you need to set the number of gigabytes that you have available for video generation. So in this case, since we're using a 3050, we've got about 30, so we can crank that up all the way to 30. And then MP4 compression is how compressed is the final MP4 clip going to be. 0 is uncompressed. However, if you're having black outputs, they recommend to leave it at 16. So again, my suggestion is start at 16, and if you want to try and improve the video quality, try and crank it up, but that will put more strain on your GPU. And here is a clip that I generated earlier using this method. And that's how you get FramePack running on RunPod on any GPU. They've got a huge range of GPUs. You can pick anything from an RTX 50 as I did to beefier machines like an L40 with 48 gigs of VRAM, all the way up to H100s with 80 gigs, or even a B200. So if you want to blaze through creating super long videos with absolutely no waiting time, this is the GPU to go for, but you will be paying $8 an hour. So lots of flexibility here on RunPod. I'll also mention that if you are planning to use FramePack a lot, when you're done using it, make sure you come over and stop the pod. If you stop the pod, the models will be downloaded, so the next time you initialize it by clicking start, it will be a lot faster. However, you will incur a storage fee for as long as you have it. And if you just want to get rid of it completely and not use up your credits, go ahead and delete it, but you will need to re-download the models the next time you boot in, and anything saved on this pod will be deleted. So make sure you download the video files that you want to keep before you delete your pod. Okay, so moving on, I'm now going to show you how you can install the G Radio locally on your own Windows machine. So this one is also really easy. Check out the GitHub link down below. That is Eli Saviel's GitHub, the creator of FramePack and also the creator of ControlNet, where he explains a little bit here about the model, but the important thing that we want is the installation. They've graciously set up a one-click installer, so all you need to do is click here and it will download for you a zip file. Unzip the file into the folder where you want to keep FramePack, and you'll see 4 folders like this. Before you do anything, click update.bat, and that will make sure that you have the latest version of FramePack. And then once it's done updating, go ahead and click run.bat, and that will finish setting up RunPack for you. It'll download all the models, and then it'll give you a localhost G Radio link, probably a 0.0.0.0 in your terminal that you can click and open up in a browser. That's it. That's all you need to do. Running it on Windows is extremely easy. Next, running it on Linux takes a couple of more steps. So you're going to want to open up a terminal in the folder where you want to download this to, and you're going to want to git clone the address. So go up here to code, grab this URL over here, or click the copy URL to clipboard, open up your terminal, type in git clone, drop in that URL, and it will start downloading the files for you. Now, once it's done downloading it, before you do anything else, you need to make sure that you have Python 3.1 installed. Depending on your Linux distro, there's going to be a bunch of different ways to go about doing that. I'll post a couple of links below on how you want to go about doing that, but you need to have that installed. Now, I have it installed here as Python 3.10. So we're going to create a virtual environment, and I have that installed separately with my system Python, which is 3.11. So we're going to now create a virtual environment that references 3.10, as this is what FramePack requires. So we're going to do that here, where we create the virtual environment specifically with Python 3.10. Then we're going to enter the virtual environment. And then once we're in here on the GitHub, there's a pip install torch Vision audio with a specific version of that. Go ahead and drop that in, as well as pip install our requirements. This is going to install all of the necessary components that you need. And then you're going to type in python space demo underscore gradio.py. Now, I'm recording this video on my Mac, which is separate from my Linux machine. So I'm going to add in the flag -- share, and that's going to give me a G Radio link that I can access on another computer. And you can see here, once again, I've got the G Radio user interface. This is a video that I created using my 3090, which, as I mentioned, took forever. And that's how you get the FramePack running on G Radio on your Windows or Linux machine. As I mentioned earlier, this works only on NVIDIA graphics cards. So if you're on AMD or Intel or a Mac, you're currently out of luck. I suggest looking at the cloud options in that situation. Now, let's finish up by looking at how we can get this running on ComfyUI. For this particular video, I'm going to set up a pod on RunPod. However, you can follow the exact same steps whether you're running on your own local Windows or Linux machine. And I'm going to grab my ComfyUI template, which again, I'll link down below. And by the way, if you're looking for more RunPod templates for different AI tools, come and check out the Discord. I have a section there where we put all of the RunPod templates that we have available. Let's adjust that to make sure I have enough space, 150, 150. And on my particular RunPod template, if you open up the environment variables, we have a whole bunch of parameters here where we will automatically download and install different models for you. So we've got things like Animate Diff, SDXL, SD3, all the various Flux models, and I will be adding Hydream to this very shortly. And I think I will add in FramePack as well. So all you'll need to do is type in a 1 where we have FramePack and it will automatically download the models for you. So for now, we're just going to grab even low VRAM. I'm going to make that 0 because we're using a 5090. Set my overrides and deploy on demand. Okay, for ComfyUI, we're going to connect a little bit differently than in FramePack. We're going to click here on connect, and we just want to wait for the services to become ready. Okay, I can see here in the logs starting server. So we should be able to jump in now. And there we have it. Now, when I ran this test previously, I did not have FramePack already set up in custom nodes. So we're going to go and check really quick first if FramePack has been added to the custom nodes manager. So unfortunately, not yet. There's this ComfyUI RH FramePack, but it's from an unknown, it's from an author that I don't know very well, and it only has 84 stars. So I'm not going to risk installing that. Instead, we're going to manually install it from this GitHub. Now, the reason I did that is if you're looking at this video at a later date, it may already be in the custom ComfyUI nodes database. So check there first. If you don't find it, follow these steps. So we're going to go ahead and click here on the code and copy this URL to the clipboard. We're going to go back to our RunPod and click on this Jupyter Lab button over here. And that opens up like a basic Linux interface where we can install a few things. Okay, once you're here, open up ComfyUI, custom nodes, and if you're doing this locally on your own machine, the folder structure will be identical. So open up your ComfyUI folder, look for the custom nodes folder, and once you're in here, you're going to want to open a terminal on your machine. If you're on Windows or Mac, please look up how to do that in the folder that you have open. I'll try and leave instructions down below if I can, but it's a very easy thing to do. Over here on RunPod, I just need to click on terminal, and you can see that I'm already located over here. On Windows, I believe you can click on the address box at the top and just type in CMD, and that will open it for you in the same folder. And on Linux, you can right click anywhere and open up a terminal in that same folder. We're going to do git clone and then paste in that URL, and that's going to download the custom node folder for us. You'll see it over here, ComfyUI FramePack wrapper. Now, we want to go into that folder. Again, there's a couple of ways to do that. You can type in CD and the folder name, in this case, ComfyUI FramePack wrapper, or you can just enter it manually and open a new terminal there. Both work. Once you're in there, you're going to want to do pip install -r requirements.txt. Okay, and that will install the custom nodes for you. Now, you're going to need to restart ComfyUI if you have it running already. So over here, we're going to go to our ComfyUI manager and restart. And the reason we want to do it this way, as the server is still running, so we won't need to reinstall or re-download anything. Now, once you've done that, you're going to want to drag in the workflow that I have linked down below. It's available for free for everyone. Even though it's a Patreon link, that's fine. Head on over. The post is open for everyone. Go ahead and download that and drag it in, and you'll get a workflow like this. Now, you'll probably see a bunch of nodes that you need to install. That's fine. Go ahead and click on Manager, install missing custom nodes, and they'll appear here. Click Install, restart your ComfyUI, and you should be good to go. You'll now be able to access the workflow. The key nodes you'll see, however, are these FramePack wrapper nodes, as well as this FramePack sampler. The way everything works is we set our start image here. Now, one cool thing about using this ComfyUI workflow, unlike the G-Radio, is that we can set both the start and the end image. So you can set that here, start image, end image. In the start image, there's this additional node, which is part of the FramePack wrapper, which finds the nearest bucket, which basically sets the resolution of the video based on the image that you upload, which you can then resize further based on your requirements. And then there's a little helper node, which allows you to output various parameters of the image. Here, we're encoding it into a vein, as well as sending it into a clip vision encoder. From here, we do several things. We send the clip vision output, which is the understanding of the image, into this FramePack sampler, as well as the starting image in a WAV format, the ending image in a WAV format, the clip vision output of the ending image into the FramePack sampler. And then over here, we send the positive prompt, the negative prompt, which we are zeroing out. So we're sending nothing as a negative prompt. And then finally, we load in the model over here. Over here, you can see a couple of models that we're using. In load clip vision, we're using this SIG clip vision patch 14 safe tensors, which we will need to install. As well as in the dual clip loader, we need the clip L safe tensors, a Lava Llama 3 FP16 safe tensors, and we're setting the type to be Hunyuan video. But then up here, the WAV is set to be the Hunyuan video WAV. So these are all models that we will need to install before we can use this. Let's just finish up by showing how the output gets sent into this WAV decoder, which then sends the images into this helper once again, which then goes into video combine, which puts everything together. So now that we understand the workflow, let's get the model set up. Now, this workflow is from Kaijugen with a few minor modifications from me. So Kaijugen has graciously put here the model links that we need. I will also be putting these down in the description below, but let's go through it pretty quickly. So up here, Kaijugen has given these two links, and these are basically two different versions of the FramePack model. We have an FP8 and a BF16 version. Depending on your GPU, you may need to choose one or the other. The BF16 is the one that has a higher requirement, whereas the FP8 will run on less powerful GPUs. We're going to go ahead and grab this one. So to install the model, you're going to want to go to Models, Diffusers, and create a folder called Ilisaviel and put the model in there. However, as I understand it, for the FramePack model, at least it should auto download. So we're going to leave it as blank for now, but if it doesn't download, that's how you do it. Next, they've given us the SIG clip model over here, which we put in the clip vision folder. And then finally, you've got the text encoder, and you also want to put in there the Lava Llama 3 vision. So that goes into the clip vision folder as well. And then you want to put these models, you want to put the clip L and your Lava Llama 3, again, FP8 or FP8 in your text encoder folder. And then of course you've got your WAV over here and you want to put that in. And that's pretty much it. I hope you found this video helpful. If you did, please don't forget to like and subscribe. And if you really want to help the channel out, please do consider supporting me on Patreon or checking out Kaijugen. Using either massively supports the channel and helps me make more of these videos. Finally, please do come by the Discord, especially if you want to check out other RunPod templates or if you want to share whatever it is you've been creating. We love to see the stuff that you make, and we love to hear what's working, what's not working, as well as help answer any questions if you're running into issues. I hope to see you guys there. Thanks so much, and I'll catch you guys in the next one.